the structure of human eye. The human eye is a spherical structure which fits in the eye socket in the skull bone. The human eye has the following parts: cornea, the transparent spherical membrane covering the front of the eye; iris, the colored diaphragm between the cornea and lens; pupil, the small hole in the iris; eye lens, it is a transparent lens made of jelly-like material; ciliary muscles, these muscles hold the lens in position; retina, the back surface of the eye; blind spot, the point at which the optic nerve leaves the eye. An image formed at this point is not sent to the brain. Aqueous humor, a clear liquid region between the cornea and the lens. Vitreous humor, the space between eye lens and retina is filled with another liquid called vitreous humor. Working of a human eye. Let us now study how the eye works. The light coming from an object enters the eye through cornea and pupil. The eye lens converges these light rays to form a real, inverted, and diminished image on the retina. The light-sensitive cells of the retina get activated with the incidence of light and generate electric signals. These electric signals are sent to the brain by the optic nerves, and the brain interprets the electrical signals in such a way that we see an image which is erect and of the same size as the object. Defects of vision. Introduction. The human eye is one of the most valuable and sensitive sense organs. It enables us to see the wonderful world and colors around us. On closing our eyes, we can identify objects to some extent by their smell, taste, sound they make, or by touch. It is, however, impossible to identify colors while closing the eyes. Thus, of all the sense organs, the human eye is the most significant one, as it enables us to see the beautiful, colorful world around us. If, due to certain abnormalities, the eye is unable to accommodate itself to various distances, then the eye is said to be defective. A defective eye's far point may be closer to the eye, or its near point may be farther away from the eye, farther than 25 centimeters. There are two common defects of the eye called myopia and hypermetropia. Defects of vision. Myopia. A person suffering from myopia or short-sightedness cannot distinctly see distant objects but can easily see near objects. The image of a distant object is not formed on the retina but in front of it. Consequently, distant objects are not distinctly visible. In other words, his or her far point is not at infinity. She or he cannot clearly see objects lying beyond a particular point called his or her far point P. Object lying between his or her far point P and his or her near point N are made distinct by the process of accommodation. Myopia is due to any one or both of the following factors. 1. The lens may be thicker, more converging than the normal eye lens. 2. The eyeball may be elongated. Due to elongation, distance between lens and retina becomes more than that for normal eye. To correct a myopic eye, the person has to wear spectacle with a concave lens of suitable focal length. Defects of vision, hypermetropia. Long-sightedness or hypermetropia is a condition where the person is able to see the objects that are distant clearly and is unable to view the nearby objects clearly. This defect arises as the image of the object that is supposed to form at the retina forms behind the retina. A person with hypermetropia can read comfortably only when reading material is kept beyond 25 cm from the eye. The eye lens has a very long focal length. The size of the eyeball is extremely small. A convex lens of a suitable power can be used to correct this defect, as it helps in bringing the image at the retina, giving it a clear view of the object. Defects of vision, presbyopia. Presbyopia is the eye's diminished ability to focus that occurs with aging. It arises from the loss of elasticity of the crystalline lens, although changes in the lens curvature from continual growth and loss of power of the ciliary muscles. They are the muscles that bend and straighten the lens, have also been postulated as its cause. Presbyopia is not a disease as such, but a condition that affects everyone at a certain age. When people develop presbyopia, they find they need to hold books, magazines, newspapers, menus, and other reading materials at arm's length in order to focus properly. When they perform work which requires the close scrutiny of the eye, such as embroidery or handwriting, they may have headaches or eye strain or feel fatigued. Eyeglasses with bifocal or progressive addition lenses, PALs, PALs, are the most common correction for presbyopia. Bifocal means 2 points of focus. The main part of the spectacle lens contains a prescription for nearsightedness or farsightedness, while the lower portion of the lens holds the stronger near prescription for close work. Dispersion of light. Rainbow is the natural phenomenon in which dispersion takes place. The cause of dispersion is that sunlight consists of 7 constituents, colors namely violet, indigo, blue, green, yellow, orange and red, popularly referred to as VIBGYOR, that have different refractive index with respect to a medium. The wavelength of each color is different, that causes the difference in velocity of the corresponding light when passing from one medium to another. This phenomenon can be observed in a lab environment using a triangular glass prism. It is a solid structure having 3 rectangular and 2 triangular surfaces. The angle between the refracting surfaces is the angle of the prism or refracting angle. The edge formed by the 2 refracting surfaces is the refracting edge. When a light ray enters one refracting surface of the prism, it bends towards the normal, and when it emerges out of the other refracting surface, it bends away from the normal. The angle between the incident ray and the emergent ray is the angle of deviation. Scattering of light, Tyndall effect. The scattering of light is an important observation in our daily life. The way light scatters off molecules in the atmosphere explains why the sky is blue and why the sun looks red at sunrise and sunset. This is because of the scattering of light. A beam of light or laser invisible in clear air or pure water will trace a visible path through colloidal particles. This is known as the Tyndall effect after its discoverer, the 19th century British physicist John Tyndall. The color of the scattered light depends on the size of the particles. The very fine particles scatter colors of all wavelengths. The large particles in size scatter colors of longer wavelengths. The examples are a headlight on a car shining through fog. When sunlight passes through a canopy of a dense forest. Why color of the sky is blue? The color of the clear sky is blue because molecules in the air scatter blue light from the sun more than they scatter red light. When we look towards the sun at sunset, we see red and orange colors because the blue light has been scattered out and away from the line of sight. The absorbed blue light is radiated in different directions. It gets scattered all around the sky. Whichever direction you look, some of the scattered blue light reaches you. Since you see the blue light from everywhere overhead, the sky looks blue. As you look closer to the horizon, the sky appears much paler in color. To reach you, the scattered blue light must pass through more air. Why danger signals are red? Whenever you may go to market or any particular location, you must have surely encountered traffic, and you might have also seen traffic lights to control the traffic, and you all would surely know that when the light turns red, it means that we have to stop. Well, it is not only with the traffic signal, but every vehicle in the world has red light at the rear end, and whenever it lightens, the vehicle at the back has to stop. The primary reason why the color red is used for danger signals is that red light is scattered the least by air molecules. The effect of scattering is inversely related to the fourth power of the wavelength of a color. Therefore, blue, which has the least wavelength of all the visible radiations, is scattered the most, and red, which has the highest wavelength of all the colors, we can see is scattered the least. Color of sun at sunrise and sunset. At sunrise or sunset, and especially when the air is dusty, the sky looks red. This is because the sun's light must travel through the atmosphere for a greater distance when it is near the horizon. The blue light is bent away from the eye altogether, while largest dust particles scatter red light to create a beautiful evening sky. As sunlight passes through the atmosphere, enough blue light is deflected, or more technically rayleigh scattered by these particles to give the atmosphere an overall blue glow. The sun itself is slightly reddened by this process because a fraction of its blue light is deflected away before it reaches our eyes.